In this video, we'll review how we find the critical z-values. So we want to find critical z-values, assume the normal distribution applies. So we have a two-tailed test with alpha equal to 0.07. So let's look at our decision diagram. Two-tailed test means that we have a critical value on both ends on either tail, and we split our alpha, so this is alpha over 2, or 0.035. That's the area on the right tail, and the area on the left tail is the same, alpha over 2, or 0.07 over 2, or 0.035. So recall that we find z-values using our TI-8384 technology using the function inverse norm. And what we put in inverse norm is area to the left. So in this case, to find this critical value here, inverse norm is 0.035. The area to the left is 0.035. So let's pull the calculator up and look at that. These are in our distributions, second distributions, and inverse norm. Area to the left, 0.035. And you may or may not have to do this paste step. Let's see. There we go. But this is maybe perhaps what yours looks like, but 0.035, and perhaps you just need to close that out with the closing parentheses. Enter negative 1.8119. We generally round our z-scores to 2 decimal places, so this would be negative 1.81. And we would be expecting a negative z-score here on the left side, negative 1.81. This is 0 at our mean. Okay, well, we know this is a symmetric graph. We know that if 0.035 here and we have 0.035 here, so from that we can tell that this z-score, this critical value, should also be 1.81. This would be the positive 1.81. However, we can check that using inverse norm. Recall its area to the left. The area to the left here is 1 minus 0.035, and you can actually enter that just like this. One minus 0.035. Enter. Enter, and see, we get the positive 1.81. Alright, that was a two-tailed test. We had to split our alpha. Let's look at another example. Here we have a left-tailed test with alpha equals 0.06. So that means the shaded area is entirely in the left tail. This area is equal to 0.06. And as we said, inverse norm, the way that function works is area to the left. And the area to the left of our critical value is 0.06. This is 0. Here's our critical value. Okay, so using our function, .06, enter, enter, negative, as we expected, 1.5547, that would be negative 1.55. And finally, let's look at a right-tailed test. In this case, we have an alpha of 0.09. So the area is all in the right tail. This area is 0.09. The question is, what's the critical value right here? Inverse norm, area to the left. The area to the left would be 1 minus 0.09. And we get a positive, as we expected, 1.34. So it's good to have your decision diagram so you can anticipate your critical value, at least the sign on your critical value, and you're ready to check that in case you enter the wrong values in the inverse norm function.